This is a tutorial video on our practice problems for Chapter 15 and 16 in our chemistry book. Please take note of the different formulas that we'll be using in this unit. Remember that pH is the negative log of the hydrogen ion concentration, or also we could call that hydronium ion concentration. The same kind of formula is used for pOH. The only difference here is that in pH you're measuring the acid concentration, and in pOH you're measuring the base concentration. Please note that there are acids and bases in almost every single solution because of the dissociation of water that's in there. If, in fact, you had the pH or the pOH and you wanted to find the concentration of the ions, you could simply use the inverse of this formula. So we've just rearranged this first equation to form the second equation. So here you're finding concentration in molarity, and it's always going to be in molarity, moles per liter, and that's what the bracket represents. So if you wanted to find the concentration in molarity of a base, again, you would take 10 to the negative power of the pOH. It just depends on what you're given in the problem. The last thing that you'll need to know is that pH and pOH, the sum of those numbers are always equal to 14. So if you have one, you can solve for the other by simply looking at the formula. Okay, so let's look at a few problems. If you look down here, you have a concentration of hydrogen bromide, and this is hydrobromic acid. So if I wanted to find the hydrogen ion concentration, it's simply the same as the concentration of the acid because you're given acid. This is an acid. Well, what is the pH of that? We just figured out from our formula. If you take the negative log of this number and you type it in your calculator, you will get 4.0. Anytime there's a 1 here, you can simply look at the negative exponent, and that's going to be equal to your pH or pOH depending on what concentration you have. Well, our pOH is just 14 minus this number, and so our pOH, or power of hydroxide ions, in this same solution is 10. Well, when we want to find out if it's acid, neutral, or basic, again, you're going to look at your pH range, and from 0 to 7 pH, or up right before 7, it's going to be an acid. Anything from 7 to 14 will be a base. So you're always going to look at your pH number, not your pOH, to determine if it's an acid or a base. In this case, our pH is 4. Since it's a 4, 4 falls in the acid range. So this solution is an acidic solution. Let's look at another section of our homework. Okay. The self-ionization of water means that water will always kind of ionize a little bit. Two water molecules will bond together to form a hydronium ion and a hydroxide ion, which is a little bit of acid and a little bit of base. That's why no matter what solution you have, you're going to have a little bit of each of the other thing, even if you've only added acid to the solution. Again, we're looking at concentration and molarity. As the temperature goes up, so will the ionization of water. In other words, it'll form more of these ions. And the ionization constant just says that if you multiply the concentration of acid times the concentration of base and molarity, you're always going to get 1 times 10 to the negative 14. Here it's asking if you have more hydrogen ion concentrations, or I'm sorry, if the hydrogen ion and hydroxide ion concentrations are equal, then this is going to be a neutral solution because they're the same. If the hydrogen ion concentration is greater than 1 times 10 to the negative 7, which is, means a pH of 7, it's going to be acidic. If you have more hydrogen ions floating around in solution, it will become more acidic. Likewise, if you have more hydroxide ions in solution, then it will become more basic. We want to look at a couple practice problems in your textbook on page 484. These practice problems are here, and they ask you to find the hydronium ion concentration and the hydroxide ion concentration. Now, I've color-coded these because all of these are acid, pHs, and the blues here are bases with regard to what they're asking for. But the first thing you need to do is look at what is the compound that you are looking at. In this case, HCl is an acid. So you can instantly tell that since this is acid, you have the hydrogen ion concentration already provided for you. This is an acid, This is the molarity, so this will be the same as the hydronium ion concentration. You could find the pH of that by taking the negative log of this number, and you would discover that it is a 4, which makes sense. It's an acid. The pOH would be 14 minus 4, so that would make it 10. Now, how do you find this hydroxide ion concentration? Well, since we know our pH, that's 1 times 10 to the negative 4, so the pH is 4. Our pOH is going to be 1 times 10 to the negative 10. If you type that in your calculator, you'll get the same answer. Here, another acid. This is an acid, so the hydronium ion concentration of this acid will be the same as the concentration of the acid. So the acid concentration, hydronium ion concentration are going to be the same here. The pH, if you look at this, it's a 3, and 14 minus 3 is 11, so our pOH is 11. That helps us find our hydroxide ion concentration, which is 1 times 10 to the negative 11. This one is a little bit different because they gave you the concentration of a base, and there's no 1 in front of it, so you'll actually have to use your calculator, and you'll have to type it in. Remember the formula for pH. Now, because we have a base, when we type in negative log of this number, we're going to actually find our pOH. Since we're plugging in a hydroxide concentration, we're going to find our pOH. So in our calculator, we'll type in negative log of 3, second EE. Second EE is another way to tell the calculator times 10 to the power of, and then there's a negative 2 here. And when you hit enter, you'll find that the pOH is 1.5. That's the power of the hydroxide ions. And the reason we know it's a pOH is because this is a base. Well, we can simply find the pH by taking 14 and subtracting 1.5. So our pH is 12.5. Now, once we find that, we can use our handy-dandy formula that says if I have a pH and I want to find the concentration, I have a pH and I want to find the concentration, I simply reverse the equation that I just did. So it's going to be 10 to the power of negative pH. So in this case, you're going to hit second log, and that's going to give you this inverse right above the log of negative 12.5. And when I hit enter, I should get 3.16 times 10 to the negative 13. And if you look, it's 3.3 times 10 to the negative 13. That's pretty darn close. I think this was supposed to be 1.4. I think I rounded a little much. Anyway, that's the answer. So let's look down here. Now, the tricky part of this one is that this one is, this calcium hydroxide base has more than one hydroxide in it. So if you think of this as calcium hydroxide, this little blocks here, this is the calcium. This green would represent the calcium, and the two hydroxides would be these two yellow blocks. So what this formula has told you is that you have 1 times 10 to the negative 4 moles of these compounds per liter of solution. That's what it's told you. But we want to know how many moles of just the hydroxide ions we have in solution. So now we'll have to compare that to if you took this compound and you broke it up. So now I have a calcium, a hydroxide, and another hydroxide. I have 2 of them, 2 moles of OHs for every 1 mole. You have 2 moles of ions right here for every 1 mole of your compound. So that means you would need to double this to find out the molarity of just the hydroxides. That's how they got 2 here. 1 times 10 to the negative 4 times 2 is 2 times 10 to the negative 4. Then if you wanted to find the hydrogen ion concentration, you can again use your formulas that you had before. Our pOH is going to be negative log. So we found our hydroxide ion concentration, 2, so it's going to be negative log of 2 times 10 to the negative 4. All right, and that's going to be 3.7. So this is our pOH because I used the OH. And if you subtract 14 minus 3.7, you're going to get 10.3. So now I can find this by using the formula that we talked about before. I have my pH and I want my hydroxide ion concentration. So I'm going to plug it in to this formula here. So if you take second log of negative 10.3, and you should get 5 times 10 to the negative 11th, 5 times 10 to the negative 11th. You get the same answer. Okay, that should get us through the first section. Now we're going to look at a couple more questions and then we'll do the next part. pH is always a measure of either hydrogen ion concentration or hydronium ion concentration. It really just depends on which one you want to look at, but they mean the same thing. Essentially, it means it's the concentration of acid in molarity. It's the equation used to calculate pH we've been using. POH is the same equation except for that you're using a different ion, and we've used these as well. So let's look at page 487, and let's do just a couple more. All right, on page 487, it asks you to determine the pH. You simply put it in your calculator using this formula, and since we're working with an acid, you can simply get this answer. You're working with an acid, you get this answer. The tricky part about these two down here is that you're not working with acids. They want the pH, or power of hydrogen ions, but they give you the base. So what you're going to find when you plug this in your calculator is actually a POH. Your POH here ends up being 4, because if you take the negative log of this number, you're going to get 4. Well, if the pH is 4, POH is 4, your pH is 10, because 14 minus 4 is 10, and there it is. Again, the POH ends up being 2 when you type this in your calculator, negative log. Again, here's your formula. The POH is 2, so my pH is 14 minus 2, which is 12, and that's how they got it. Those are your practice problems. These you want to be careful about, that you're paying attention to what it's asking. Here it gave you an acid. The negative log of this number is 9. That's how I went from hydrogen ions to pH. It's the same thing we've been doing. To find POH, I simply take 14 minus 9 and I get 5. Now when I want to know if it's an acid or a base, again, I only look at pH. So you're only looking at this. If it's greater than 7, it's a base. If it's less than 7, it's an acid. If it's equal to 7, it's neutral, like water. All right? Now to find POH, to go from POH to OH, again, you're going to use the same formulas. I want this, and I have this. So I'm going to take 10 to the negative power of that number. And when you plug that in, 1 times 10 to the negative 5, and it's molarity. Now the next one we do, it's a little bit trickier because you have to, it's not just a 1 number. You can still type it in your calculator. The negative log of this number, 4.1 second EE negative 2, and you get 1.38. Now, is that going to go here or here? Well, since it's a base, you're going to put it here, because this is the power. They have to correspond with each other. This is the hydroxide, this is the power of the hydroxide. So if you subtract that from 14, you get 12.61. And then in order to go from pH to the hydrogen ion concentration, again, we've done that several times. The negative 10 to the negative pH will give you the concentration. So if we type it in, 10 to the negative, and the pH was 12.61, the answer is 2.45 times 10 to the negative 13 molarity. Okay, stay tuned for the next video to continue the packet.